Dear students, how are you? Hopefully you are well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today, our discussion topic is circle. And this circle is very important for our everyday life because we need to know the history behind the circle. The circle is the word come from a Greek word named kirkos, and the meaning of it is hoop or ring. Human concept is natural to the circle, and three Greek philosophers named Euclid, Aristotle and Plato, they have invented the process of the circle, and Ryan purpose in 1700 find the process to find out the formula of the circle. The circle is very important to our everyday life. At the case of in our geometry part, especially the coordinate geometry, then there is some calculus part, and there is also our web designer or computer designing part. All the parts are very important, the circle concept. Similarly, it's very important to our everyday or the modern communication, because at the ancient time a wheel is invented at the ancient time, and later on it actually makes revolutionary, and we have seen this, the communication part. Thank you. Dear students, today our topic as usual, that is circle, and in this type we are trying to solve some theorem, and today we are discussing about 21, 22, 23 and 24, this fourth theorem, and your HW will be theorem 23 and 24. However, so this is our lecture 2, and here first we are going for the theorem. It's okay, but you need to know some basic about the circle. We know this, but just we are trying to remember. Okay, our first there is some topic, and the first part is arc of a circle. What is the arc of a circle? The arc of a circle will be, if we take 2 points on a circle, then there will be 2 parts here and here. That means just we are thinking that there is 2 parts, and if we cut from here and here, then we get actually 2 parts. So one part has the maximum part, and another way there is some part, and the maximum part is known as the major arc. It is the major arc, and it is the smaller part, and the smaller part is known as the minor arc. Okay, so this is a circle. In this circle we can understand what actually the arc of this circle, and here 3 things we need to know, that is what is the point inside, outside and on the circle. If any point is here, that means this point is outside the circle. If any point is here or lie in here, then we can say that this point is inner side of the circle or inside the circle, and if any point is there, then we can say the point is on the circle. Now move on to our second part, that is radius. What is radius? Radius is nothing but a point which will be just added the center to the surface. If this is the center of the circle, then from the center to the surface, if we draw a line, that is the radius. So this is the radius. If I am joining these 2 parts, this will be the radius, this will be the radius, and this will be also the radius. Okay, so this is the radius which is generally joining 2 points. One is center, another is the point which is on the circle. Okay, third part is chord. What is the chord of the circle? Chord of the circle is, if we joining 2 points, but that 2 point must have 2 on the circle. That means suppose there is a point on the circle and there is a point on the circle. If we add these 2 points, then this is the chord. If we are thinking that this is the point on the circle and this is the point on the circle, and if we add these 2, then we get the chord of the circle. Okay, so the chord of the circle can be this, also this. But it is very similar to something we know, that is what? The diameter isn't it? Okay, my dear students, the diameter is nothing but a chord, but the greatest chord of a circle is named as the diameter, which must have to gone through the center. So if any chord goes through the center, name as the diameter. So the diameter should be this way, and this is also the chord. This is the diameter, and also it is a chord. This diameter is also the chord. So any line is joining to side on the circle and goes through the point or center is known as the diameter. Okay, now the relationship between we can understand the relationship between chord and diameter. Now we have to think about the relationship between radius and diameter. Okay, the radius is generally denoted by r and the diameter is generally denoted by d, and the relation between these two is d equal to r. Why? Because when we are talking about that this is the radius, that means actually this part is radius, similarly this part is also radius. So two radius, if we add, then we get the diameter. So we can say d equal to 2r. So radius and diameter has a relationship, and that is this. Now we move on to our second part, that is the angle related part. Here so now we are thinking about the angle. To understand the inscribed angle, we have to think about the total surface of the circle. That means if we draw an angle like this or like this all actually the angle named as the inscribed angle. This all the angle named as the inscribed angle. So this is a inscribed angle, this is also a inscribed angle. So our angle, if it is created on the surface of the circle, that is named as the inscribed angle. So what about the central angle? Central angle is must have to think about the center first. If this is the center and we are trying to draw an angle on the center, that is known as the central angle. So this is a central angle and this will be also a central angle, but named as the reflex central angle. Reflex central angle. Okay. However, so the angle which is created on the center named as the central angle, and the angle created on the surface of the circle is named as the inscribed angle. So my question is, what's the relationship between this? The relation is, this is, if this angle is 30 degree, then this angle must be 60 degree. If this angle is 60 degree, this angle must be 120 degree. What is this? Actually, I am talking about the relationship between central angle and the inscribed angle, and the relationship between the central angle and inscribed angle is, if we multiply inscribed angle into 2, we get the central angle. So this is the central angle which is denoted by C, is the inscribed angle denoted by I. If we multiply I with 2, that means inscribed angle into 2, we get the central angle. So here look at the board. If our inscribed angle is 30 and we are multiplying it by 2, then we get the central angle, that is 60. So yes, the relationship between these two is correct. Similarly, this two is also correct. So this is the relationship between the central angle and the inscribed angle. Now one CW for you, that is, if the central angle is 120, so what about the inscribed angle? You have to find what about the inscribed angle. Okay, so this is your CW for this part. So the angle in a circle standing on the same arc are equal. This is our theorem number 21. So theorem number 21 says what? Angles in a circle standing on the same arc are equal. That means Suppose we are thinking that this is our required arc, that is the BD. We are thinking about this arc, and if we draw two angles on this arc, suppose BAD and BED, then these two angles must be equal. Why? Angles in a circle standing on the same arc are equal. Whose are equal? The angles are equal. Okay. Now, our special nomination says the center O on the arc BD. So, this is our center and our arc is BD. We are thinking about the arc is BD and center is O. Okay. So, BAD and BED be two angles in the circle. Since we are thinking that our arc is BD, so on the arc BD, the two angle is BAD, that means this angle, and BED, that is this angle. So these two angles are also given. Now it's required to prove that BAD is equals to BED. According to our scheme, so BAD must have to equal BED. Okay, now proof. In this proof part, there is talking about the arc BD subtend an angle BOD at O. So the arc BD subtend an angle BOD. So since here O is our center, so this for this O and BD is our arc. If we add BO and DO, then we get actually what? Central angle, isn't it? So actually we get a central angle. So BO and OD, that means BOD is our central angle. Here just I have been talking about a relationship between the central angle and the inscribed angle. That was the central angle must have to be double of the inscribed angle. So from that formula we can say that BOD, that is the central angle, is equals to what? The inscribed angle BAD. 2 into BAD. Similarly, our central angle BOD is equals to the inscribed angle BAD. And here, from this equation, we can say the left side is equal. That's why, since our left side is equal, that's why right side is also equal. So from here, 2 is done. So this equal this. That means this angle is equals to this angle. That is our proof. Okay, this is the theorem number 22, and this theorem says the angle in a semicircle is a right angle. So here, what the angle of a semicircle would be a right angle, and what about the right angle? That means actually 90 degree. Okay, now we are going for a spatial nomination. Spatial nomination says the AB is a diameter with center O. So here is a circle. In this circle, there is a center O, and AB should be the diameter. Since this is also a chord which is actually goes through the center. Okay. Now the ACB is the angle. ACB is the angle of a semicircle, isn't it? Semicircle, that is ABC. This is a semicircle. In this semicircle, the angle ACB is actually subtended by the semicircle, and it's required to prove that our ACB angle must be 90 degree. Why? Because he is talking about that you have to prove the angle must be right angle. That's why you have to prove that ACB equals to 90 degree. Now the construction part says that we have to take a point D which must be located the opposite of C. What is talking about? Take a point on D on a circle on the opposite side of the circle where C is located. So where C is located, we have to take a point D which must be lie on opposite of C. Okay. Now proof says that angles subtending on the arc ADB. So the ADB in this actually surface, the angle ACB is created, and this ACB must be half of AOB. Why? Because AOB is our what? Central angle, and ACB is our What? That must be the inscribed angle. So here the relation must have to be ACB, that angle equals to half of AOB. But in this part, since this is the diameter, so we can say this nothing but the 180 degree. Since the AOB is equals to 180 degree, or you may also write that these are two right angle. So the angle ACB is equals to half into 180, and here we get finally ACB equals to 90 degree. This is our required proof. So very easy theorem also for us, but here one thing you must have to add in your mind, that is we are thinking about this angle and this was in our semicircle, and that must be on the surface ADB, where we have one concept we have to work, that is the inscribed angle and the central angle. But in this case central angle is 180 or 2 right angle, so you may write it the 2 right angle. So 100 half into you may also go for 2 right angle, that means 90 degree or 1 right angle. You may go for this way also. Okay, thank you. Okay, so now this is theorem number 23, and this is very important theorem for this lecture, as well as this will be test for your the MT exam upcoming, and as well as your SSC exam too. So in this theorem 23, here the question says that the sum of two opposite angles of what? Of a quadrilateral inscribed, which must be inscribed in a circle, is 2 right angle. What? So here the sum of two opposite angles, which is the quadrilateral, and this quadrilateral is inscribed in a circle, and total angle must be 2 right angle. So now our special nomination is, suppose ABCD, this is our quadrilateral which is inscribed in the circle having the center O. So from here we have to prove what? We have to prove the opposite angle, the sum of two opposite angle. If we are thinking that this is our angle, so the opposite angle of it must be this, and according to our question we have to prove that the sum of two opposite angles of a quadrilateral inscribed in a circle is 2 right angle. That means this angle plus this angle is equals to 2 right angle. Similarly here this is also the angle and it is also angle, so the sum of these two angles are also 2 right angle. So it's required to prove that ABC plus ADC, that means this two triangle is equals to 2 right angle, and BSC equals to BCD, that means this angle plus this angle is also 2 right angle. Now we are going for our some construction. Here just AO and OC must be joined. Now we are going for our proof part. Okay, to before going to our proof part, we are just re-summarize the fact that here we are thinking, or the what is our given? It is the given part of the quadrilateral. Quadrilateral is ABCD, which is inscribed in a circle, and this circle has the center O, and we have to prove that the opposite side, that means this plus is equals to actually 2 right angle, as well as this angle plus this angle equals to 1 right angle. And another thing, that is the construction, that is AO and OC must have to be joined. Now we are going for the proof part. Here, standing on the same arc ABC, so when we are going for the arc ABC, in this on this arc, this is our what? Central angle, and this is our inscribed angle. This is our central angle, this is our inscribed angle. So what's the relationship between inscribed and the central angle? Yes, you know that the central angle is equals to 2 into inscribed angle. Okay. Similarly, when we are going for this arc ADC, when we are going for the arc ADC, on the time the angle ABC, that will be our inscribed angle, and this angle, this is the reflex AOC. It is the very important thing. Reflex AOC, what does it means actually? Reflex AOC means that this was our normal angle, and the other part of that angle is generally known as the reflex angle. So the reflex angle is our central angle, and this is our inscribed angle, and here the inscribed angle must be double of the reflex angle. That's why we are writing here the reflex of AOC is equals to 2 into ABC. So this is our equation number 1, this is our equation number 2, and here if we are adding these two equations, then we get this part plus this part is equals to this part plus this part. Okay, but here what we have been just observing from here our total are circle, and we know here we may get the 4 right angle, because the sum of the angle from the circle is 4 right angle or 360. We know that from that part we can say that this 2 is equals to 4 right angle. Now since this is our 4 right angle, so this part must have to be 4 right angle. That's why writing this part equals to 4 right angle. If 2 is divided by both sides, then we get this part equals to 2 right angle. What we have to do? Proof. And since these two are the sum of these two parts are 2 right angle, then it similarly we can say the opposite two angle, the sum of the opposite two angle are also what? 2 right angle. My dear students, I am just trying to present this theorem very easily to you, because this theorem is very important for your upcoming all exams. So what we have been done, you should have to write right now the theorem so that you can get a very good result in your exam. So what we have been done, I am just going for the another re-summarizing for the proof part. That is we have to think for this this arc. When we are going for this arc, this angle and this angle will be calculated. When we are going for this arc, then this angle and this angle will be going for the calculation. Then just adding this two part and adding this two part, and this is our 4 right angle, then we get our final proof. Thank you. Okay, so this is our theorem number 24, and this is the last theorem for this lecture. And this 24 number theorem is also very important as 23. However, the theorem says that two opposite angles of a quadrilateral are supplementary. Four vertices of the quadrilateral are conlinear. So if they are supplementary, so we have to prove that the 4 vertices of the quadrilateral are concyclic. Okay, what does the concyclic mean? Concyclic means con, that means same. Con, that means same. So concyclic, that means all the points remain on the circle. Similarly, when we are going for conlinear, that means all the point will remain in a straight line. That is called the conlinear. So this is conlinear, and if any point or if some point remain on the circle, that is called a concyclic. Okay. Here, special nomination of this theorem is, let ABC be the quadrilateral with angle ABC plus ADC equal 180. Since we are talking about the supplementary, the angles are supplementary, that's why ABC and ADC, that means these two angles from this quadrilateral are 180 degree or 2 right angle, what we have seen just proved before at the theorem number 23. Okay, so it's required to prove that ABCD are concyclic. That means a circle, if there is exist, then every ABCD, all points must have to go on that circle. Okay, now construction says ABC are not conlinear. Since ABC are not collinear, yes, ABC are not collinear, that's why there must be exist a circle and the point must be go through the circle. There exists a circle which passes through the 3 points. Since these 3 are not collinear. Okay, and here we're thinking for AD is a line which has actually intersected at point E and our join C and E. So in the drawing part, we have been doing what actually CE is the point, or E is the point which is actually cut by the circle, so that E is the point which actually intersect the point AD, and EDC must have to be joined. Now proof. At the case of proof, we can say that ABC plus ABC plus AEC equals to 180. Okay, but we know that ABC and ADC was 180, what was our given. From these two, we can say our ADC and ABC are equal. So AEC is equals to ADC. But it's impossible. Since it's impossible, since in the triangle CED, in this triangle, this angle and this angle are equal. So E and D points cannot be the different point. E and D actually cannot be the different point. That's why D point must be lie on the E point, or E point last have to be lie on the D point, where the circle will also go through the D point. So we can say that the D point must have to lie on E point. So there is no existence of that point. So from this here we can say that therefore E and D point cannot be the different point. These two are the same point. So we can say the ABCD are the concyclic. So concyclic, that means actually ABCD all the points are remain on the circle. So I am just going for the summarize for this proof part. In this proof part or total part here, since they are talking about the supplementary, that's why when we are going for ABCD quadrilateral, that's why this angle and this angle's addition must be 180 or 2 right angle. Then when we are going for this triangle or this quadrilateral ABCD, then we are talking about this angle and this angle, sum of these two are what, 180. So from that two part, this and this, we can say this angle is equals to this angle. And we are thinking that I think this is totally impossible. Since these two are totally impossible, so D point must have to lie on E point. So if D is lie on E point, then ABCD will be lie on the circle. So we can say the ABCD points are concyclic. Okay, and that's all for today's lecture. Thank you, dear students, for being your patient, and hopefully you are doing your work, and that's all. Thank you.